What is the strangest thing humans have found on the moon? It's not aliens, nor is it a base, but something that shouldn't exist. With the unveiling of our crude lunar lander, this discovery becomes crucial. It's been over half a century since Apollo astronauts last set foot on the moon. No human footprints have graced that land since, but dozens of probes were sent later. Some successfully landed. Some flew by, and some were deliberately crashed into the moon to see what kind of splash they would make. Overall, the moon is a celestial body most played with and studied by humans, even after decades of research. The moon remains full of mysteries. Whether it's how it stores heat, or the principle of electrical conductivity, or even the properties of its soil, we still know very little. It's as if the universe, the more you research, the more problems you find, like expecting something when digging, but finding something else. After digging and bringing it back, a series of discoveries, of chemical traces that shouldn't exist, baffled scientists for decades. You might think scientific discoveries immediately change everything, but the real scientific process is very slow. Sometimes everyone notices, but no one believes it. This all started in 1976, when the Soviet Union launched an unmanned probe called Lunar 24 to the moon. This was their last mission, to dig for lunar soil. No one paid attention to this mission then. It wasn't the first time, and it wasn't on a large scale, but it quietly did something significant. It drilled about 2 meters into the lunar surface and brought back a small sample of soil. The sample weighed only about 170 grams, about the size of a baseball. Though not much. But within this narrow soil sample, some strange things appeared. Traces of water. About 0.1% of the sample contained water, and the deeper you studied the sample, the more water you found. This should have been a big deal. But quite the opposite. Scientists thought the water might have come from Earth, that the sample was contaminated, perhaps from the lander, or from equipment on Earth, because textbooks clearly stated, the moon is dry. It cannot have water. And this wasn't the first time. Before this, similar hydrogen signals were found in soil brought back by Apollo astronauts. So, these clues that should have caused a stir were ignored in the corners of lab reports. For decades, no one mentioned them again. Until the turn of the century, when people started to reconsider, did we miss something important? But by the time we were ready to investigate further, the moon was ready to present us with more challenges. If you were to go to the edges of craters, in the lunar polar regions, you would see an almost unnatural sight, not because something is there, but because nothing is there, not even light. Only perpetual shadows that have never moved in billions of years. These areas are called permanently shadowed regions. Why is that? Because the moon's axial tilt is very small, only about 1.5 degrees. This means, when sunlight hits the poles, it sweeps almost horizontally across the lunar surface. The craters are large and deep, so sunlight cannot penetrate. Thus, these places have hardly seen direct sunlight in the history of the solar system. Not only are they cold with no heat circulation, the coldest spots can reach below 240 degrees Celsius. Colder than Pluto, which is far away. It's arguably the coldest place in the solar system. Scientists began pondering in the 1990s if comets or asteroids had hit the moon and brought water with them. Could some of that water vapor have drifted into these craters and become frozen and never left? This idea quickly caught on because it implied the moon might not be a dead rock. It could be a resource depot, a future refueling station. Since then, all eyes have been on the moon as a potential source of water, and a vital resource for future space exploration. The search for lunar water continues, all focused on the poles of the moon. Watching from Earth was no longer enough. We had to get closer and see for ourselves. But the problem was, these most promising areas were also the hardest to reach. Complex terrain and no light. Solar panels would be useless there. But the temptation was too great. What if there really was ice? So mission after mission was launched. The goal was clear, find solid proof. And then something strange happened. Scientists suspected ice. So what was the next step? Send a scout to take a look, but landing directly was too risky. So the first few missions just orbited and watched. The first was NASA's Clementine in 1994. It wasn't looking for water. It was mainly mapping the moon. Most of the surface, and confirming the polar regions, had those permanently shadowed craters, but it lacked the right instruments, so it couldn't confirm if there was ice in the shadows. Then in 1998, NASA launched Lunar Prospector. This one was specifically looking for water. It scanned the moon with a special instrument and found abundant hydrogen signals, especially in the shadowed areas. Scientists were thrilled. Estimates suggested there could be tens of millions, even hundreds of millions of tons of ice. This wasn't just a bit of water. It was a discovery that could change everything. But then another problem arose. Finding hydrogen doesn't mean finding water. It could be part of the soil or locked in minerals. The instrument couldn't tell the difference. It could only tell us there was hydrogen-rich material, but not if it was part of water. So what was it? In fact, even an orbiting spacecraft couldn't see it. So it wasn't solid proof. There was data, there were clues, but no definitive confirmation. It was like the moon was saying it had a treasure, but wouldn't let them open it. So scientists thought, if we can't see it from orbit, let's just do it. Let's crash into it. You heard that right. Crash into the moon. The logic was simple. If ice was hidden in the crater and we couldn't see it from above, then we'd smash something into it to blast the material out of the crater, so it would fly into sunlight, and we could see it. This method was crude but effective. The first attempt was by Lunar Prospector. After completing its mapping mission in 1999, it crashed into a crater near the lunar South Pole. But unfortunately, the attempt failed. No water was detected. The results were inconclusive. Some said the impact angle was wrong. Others said it hit the right spot. 10 years after the failed impact, NASA's LCROSS mission in 2009 brought a breakthrough. This time, they did something clever. They brought a Vanguard, the rocket body that launched them. They first used this large metal mass like a cannonball to smash into a crater near the South Pole called Cahill. A few minutes later, the LCROSS spacecraft itself followed the same trajectory, flying through the debris plume from the impact to analyze it on site. This time it was a success. The instruments detected water vapor in the plume. This wasn't an implication. It was measurable water. Not just water, but also methane and ammonia. This was the first time humans truly touched water on the moon. Headlines around the world reported the event. Scientists celebrated with champagne. It felt like a decades-old mystery was finally solved, but new questions quickly arose. They found water. But how much water was there? Was it solid ice? Or ice mixed with soil? Most importantly, was it easy to mine? LCROSS gave us an answer, but it was destroyed in the impact, unable to provide more information. We only knew there was water at that specific spot, but the full picture of the moon remained a mystery. So we continued to explore. We are still exploring. We are still exploring. We are still exploring. We are still exploring. For a long time, everyone's idea was straightforward. They thought if the moon had water, it would definitely be hidden in the coldest, darkest permanent shadows. This area never sees sunlight. It's like a giant natural freezer. Ice could stay there for billions of years. This logic makes sense. But the moon always surprises us. Orbiting probes, like NASA's Lunar Reconnaissance Orbiter since 9. The Lunar Reconnaissance Orbiter and India's Chandrayaan-1. They started finding faint water molecule signals outside these giant freezers on the sunlit lunar surface. This really confused everyone. Finding water in sunlit areas, where daytime temperatures can reach over 100 degrees Celsius. Wouldn't water have evaporated long ago? The even more baffling part came later. Scientists discovered these water signals weren't always present. They seemed to have a schedule. At noon, when the sun is strongest and the surface is hottest, the water signals weakened or even disappeared completely. But as evening approached, when the ground cooled down, the signals returned. What is this? Is the moon sweating? It sweats in the heat of the day and reabsorbs it at night. This phenomenon defies understanding. Remember, the moon is a vacuum. No atmosphere. No pressure, no wind, rain, or thunder. On Earth, water evaporates and condenses in clouds and rain. That's called the water cycle. But the moon is barren. Where would its water cycle come from? This is definitely a top mystery the moon has thrown at us. So where does this water come from? Scientists scratched their heads and proposed a few possibilities. One theory is it was delivered from outer space. Countless tiny meteoroids like dust hit the moon every day. They might carry some water themselves. Or they could hit minerals in the lunar soil, releasing trapped water. Another theory is more interesting. It's said to be blown out by the sun. The sun constantly emits a stream of charged particles, what we call solar wind. This wind hits the moon, and the particles collide with oxygen in the lunar soil, synthesizing water molecules on the spot, regardless of the source. This discovery completely changed the game. It means we might not have to go to those dark, cold, and extremely difficult to develop polar craters. Perhaps the entire lunar surface is thinly moistened with a layer of water. It just depends if we can collect it. This instantly expanded the potential sites for future lunar bases exponentially. This tantalizing possibility directly led to the next generation of missions. So in 2023, Indian scientists also took on this ultimate mystery, Chandrayaan-3 lander probe. Its target was the South Pole, which scientists believe is the region with the highest concentration of frozen water. This was the first time humans sent a probe to the South Pole. Everyone held their breath, waiting for news from the rover Pragyan about finding ice. The rover started moving. Using lasers and X-rays, it analyzed the soil samples. What were the results? Iron, aluminum. Everything was there except ice. No ice means no water. Everyone was stunned. Where was the promised water? It was clearly marked on the map. Did we get it all wrong before? Or is the water hidden too deep for the rover's small shovel to reach before anyone could figure it out? The 14-day lunar night arrived. Temperatures plummeted to over 100 degrees Celsius. Chandrayaan-3 couldn't survive. It fell silent forever, leaving us with an even bigger mystery than before. But Chandrayaan-3 wasn't a wasted effort. Before its demise, it accidentally discovered a key clue with a temperature probe. It measured the lunar soil temperature, finding the surface scorching hot from the sun, over 60 degrees Celsius, but just 8 centimeters deeper. The temperature dropped to 10 degrees Celsius. Such a huge temperature difference. What does this indicate? It shows that the uppermost layer of lunar soil acts like a thick insulating blanket, preventing external heat from penetrating. This perfectly explains the heat from outside simply cannot get in. This perfectly explains it. Why is the lunar rover on the surface? Found nothing. Because water ice is likely hidden just a few centimeters below the surface. Safely hidden. So it's not that there's no water, but our shovels were too short. So the problem isn't whether the moon is dry, but whether our tools are sharp enough to dig properly. If this is true, then the next lander won't need to fly farther or see clearer. It will just need a more powerful drill. For decades, searching for lunar water was considered a scientific curiosity, a way to better understand lunar history, geology, and how water moves in the solar system. But that's no longer the primary reason for interest. Today, lunar water means something more immediate. A stepping stone for humanity's ascent into space, and a foundation for future space bases. Because if we can find usable water on the moon, enough to extract, purify, and store, it unlocks everything else. First, it makes long-term lunar missions possible. Water is heavy. Launching water from Earth is expensive. Water transported there is worth its weight in gold. But if astronauts can get water locally, they'll need to carry less supplies. This water can be used for drinking, cooking, cleaning, or cooling equipment, without relying on continuous resupply from Earth. Second, water can be broken down into hydrogen and oxygen, the same fuel combination used by many modern rockets. If we can build a system to extract water ice and convert it into propellant, then the moon becomes more than just a destination. It becomes a refueling station, a place where spacecraft can top up before heading deeper into space, to Mars, asteroids, or beyond. This changes the entire calculation. Currently, every mission must carry all its fuel from the start. But establishing a resource depot on the moon could lighten the load. Launching from the moon is also easier. Its gravity is only 1/6 of Earth's, meaning less energy, lower costs, and greater flexibility. Spacecraft launching from the moon won't need massive rockets. They'll just need a push. Third, local water changes how we build. It can support closed-loop life support systems, recycling waste into usable resources. It can even help grow food. Some plants can grow in lunar soil under controlled conditions, but they still need water. If we find enough water, future habitats may not rely entirely on resupply, airdrops, or water payloads. This could be pivotal for future human space exploration, while it's still uncertain how much water is available, or how easy it is to access, because all these fuel depots and missions beyond the moon are only possible if we can first extract that water, which brings us to the final question. Despite all the missions, data, and optimism, the fact is, we still don't have a clear path. Every time we think we figured out the moon, it throws us something new. A contradictory reading, a missing signal, an unexpected result. And this pattern repeats. We saw strong light signals from orbit, but no light in the soil upon landing. We found signs of water vapor and impact plumes, but no frost, no ice caps, no visible accumulation, even craters that never see sunlight, places cold enough to freeze ice for billions of years. High-resolution cameras still haven't captured anything clearly. That looks like ice. Instead, we get ambiguous results. Shallow probes found nothing. The water detected by instruments seemed to vanish in daylight. Rovers passed over craters that should have been full of frozen material, only to find more dust. Even new technologies like ShadowCam, despite its ability to image the darkest places on the moon, still haven't found any ice. The mystery of lunar water continues to deepen. We need a breakthrough, but scientists haven't revealed the clarity they hoped for. Reflecting ice cubes, this raises a disturbing question. What if we on the moon have been wrong about how to store water? What if the model needs correction? Or worse, what if water does exist, but it's so sparse and buried so deep, or chemically bound to the soil so tightly that we're not ready to access it? What then? Optimistically, perhaps our tools, though precise, aren't good enough. Our orbiters are like eyes suspended in the sky, seeing far but unable to touch. What about landers and rovers? They're like fingertips, able to touch but not dig deep. All our probes feel like scratching an itch, always feeling just a little bit short of the spectrum. The data returned is also full of riddles. It tells us there's something here, but not if it's in the water or in the rocks. It tells us this area is bright, but not if the brightness comes from frost or some special mineral. But the human dictionary seems to have no room for the word give up. Quite the opposite. The more mysterious it gets, the more our curiosity is ignited. New missions are lining up. Stronger landers are being built. All eyes are still fixed there. The place we firmly believe holds treasure. The next mission might bring a more advanced Lunar shovel. It will carry a deeper drill, a smarter extraction system, no more probing, but a definitive breakthrough. To pierce that final layer, from beneath that insulating regolith, scoop up a handful of icy, solid future. Of course, the moon might play another trick on us, revealing more mysteries. And when our Lunar shovel finally scoops up that icy, solid future, a new era, grander than the moon landing itself, will begin. By then, this blue planet beneath our feet will no longer be a cradle of renown, but our harbor for sailing the sea of stars.